trigonometric function. What should we learn? Evaluate and graph inverse sine function. Evaluate and graph other inverse trigonometric function. Evaluate compositions of trigonometric function. Inverse function, sine function. Inverse sine function. We have known that for a function to have an inverse function, it must be 1-to-1. That is, it must pass the horizontal line test. In figure 4.67, it is obviously that y is equal to sine x does not pass the test because different value of x yield the same y value. However, when you restrict the domain to the interval negative pi over 2 less than x less than pi over 2 corresponding to the block portion of the graph in figure 4.67, the following properties hold. Number 1, on the interval negative pi over 2 pi and pi over 2, the function y is equal to sine x is increasing. Number 2, on the interval negative pi over 2 and pi over 2, y is equal to sine x takes on its full range of the values negative 1 less than sine x less than 1. On the interval negative pi over 2 pi over 2 is equal to y is equal to sine x is 1-to-1. So on the restricted domain negative pi over 2 less than x less than pi over 2, y is sine x has a unique inverse function called the inverse sine function. It is denoted by y is equal to arc sine x, or y is equal to sine negative 1 x. The notation sine to the power of negative 1 x is consistent with the inverse function notation f to the power of negative 1 x. The arc sine x notation, whereas the arc sine of x comes from the association of central angle with its intercepted arc length on a unit circle. So arc sine x means the angle or arc whose sine is x. Both notation arc sine x and sine negative to the power of negative 1 x are commonly used in mathematics. So remember that sine to the power of negative 1 x denote that inverse sine function rather than 1 over sine x. The values of arc sine x lie in interval negative pi over 2 less than arc sine x negative less than negative pi over 2. Define of the inverse sine function. Example 1. Evaluating the inverse sine function. If possible, find the exact value. Solution. Because sine negative pi over 6 is equal to negative 1/2 and negative pi over 6 lies in negative pi over 2 and negative pi over 2. It follows that arc sine negative 1/2 is equal to negative pi over 6. Angle whose sine is negative 1/2. Example 1 b. Because its sine negative pi over 3 is equal to square root of 3 over 2 and pi over 3 lies in negative pi over 2 and pi over 2. It follows that sine to the power of negative 1 square root of 3 over 2 is equal to pi over 3. Angle of sine is negative 3 is pi 3 square root of 3 over 2. It is not possible to evaluate y is equal to sine to the power of negative 1 x as x is equal to 2 because there is no angle whose sine is 2. Remember that the domain of the inverse sine function is negative 1 and 1. Sketch a graph of y is equals to arc sine x by hand. Solution. Definition the equation y is equal to arc sine x and sine y is equal to x are equivalent for negative pi over 2 less than or equal to y less than or equal to pi over 2. So the graph are the same for the interval negative pi over 2 and negative pi over 2. You can assign values to y in the second equation to make a table of values. Look at the table. Example 2 solution. Then plot the points and connect them with a smooth curve. The resulting graph of y is equal to arc sine x is shown in the figure 4. Note that it is the reflection in the line y is equal to x of the black portion of the graph in figures 4.67. Remember that the domain of a y is equal to arc sine x is the closed interval negative 1 and 1. The range is the closed interval negative pi over 2 and negative pi over 2.